Hello and welcome to my YouTube channel. In this video, we will install an SSL certificate in our Apache web server. To be more specific, we will install the self-signed certificate. At the end of the video, our Apache web server will be listening on the requests on secure port 443, also known as HTTPS. Previously, we manually installed and configured the Apache HTTPD server in Rocky Linux. If you have not checked that video yet, make sure to check it out. The link is in the description. Otherwise, I assume that you already have installed and configured the Apache HTTPD server, which is running on insecure port 80. Before we install the SSL certificate, let's first understand what is an SSL and SSL certificate. SSL stands for Secure Sockets Layer, a global standard security technology that enables encrypted communication between a web browser and a web server. If you are doing an online business, for example, you're accepting the sensitive information from the customers, such as their credit card information, social insurance number, usernames and passwords, etc., you must have a mechanism in place to prevent your customers' data being stolen by the hackers. This is exactly where an SSL comes into place. In short, it allows the private conversations in between the intended parties only. SSL certificate, on the other hand, is a digital identity document which is issued to your organization, and it validates the authenticity of the website. In plain words, SSL certificate makes sure that the website you are trying to access, it actually belongs to the organization which you are intended to deal with. So how do we get an SSL certificate? Usually the SSL certificate is issued by a certificate authority, which is also known as CA. The process looks like this. First, organization collects the information about their website or websites if they have multiple. Then they define the SSL certificate requirements. The certificate can be a single domain certificate only, which works for one domain, and a multi-domain, which works for a domain and its subdomains, or a wildcard certificate. Once the requirement is defined, then the CA or the certificate authority is contacted. Some companies, they run their own public key infrastructure within. So in that case, whoever is requesting the certificate, they will contact their PKI department. Next, the CA will validate the identity of the organization. Think about the CA as a bank. A bank will not issue you a loan until they verify your history, such as credit history or criminal record. Similarly, CA validates the identification of the organization through different validation steps. Sometimes they may go with extended validation, which is a thorough background check of the organization. Often it is done by the domain validation only. Once the validation process is completed, CA finally issues a certificate which you can install in your web servers. Let's talk about what is a self-signed certificate. Self-signed certificate is created and signed by self. Self in this case could be the administrator of the web server or whoever is requesting the certificate. In other words, self-signed certificate is neither signed by the certificate authority nor by the PKI. So how do we create a self-signed certificate? Since we are not going to certificate authority, we don't have to pay anything, and we can create the self-signed certificates within our Linux box. All you have to do is create the private key first, or use the existing key if you already have one. Then create a CSR, create the certificate using the openssl utility, and finally you can install that certificate in your web server. Here I have HTTPD running in a virtual machine, and we will test what it means to have an HTTPD server listening on port 80. Port 80 is also known as HTTP port, which basically is not a secure port, and everything, whatever flows over this port, can be traced by the hackers. To demonstrate it, I'm going to hit the localhost web page. At the background we have Wireshark running, which is listening for port 80 requests on localhost loopback address. As you can see, we have a static web page with the two text fields on it being served by our Apache web server. Since we are not using any encryption on the way, if I do enter the username information in here, first name and the last name, you will see once we click on submit button, the data is being recorded by the Wireshark as well in the background. Don't worry about this not found page because we are trying to access a page on the web server which doesn't exist. That's not the point. The point is to check how the data can be seen by the hackers. When checking the Wireshark, you can see we have a bunch of requests being made. The important part we want to see is the post request. If we click on the post request, at the bottom of the page we have HTTP protocol running. You can already see that the parameters we pasted in the form are being sent in a plain text to the web server. So in this case, if a hacker was actually listening to your traffic, they will be able to see the username or the password, or let's say if it was a bank detail or credit card information, they will be easily able to obtain that too. This is the limitation of running a web server on port 80. We will fix that by installing an SSL certificate. Previously, we already have discussed the way which a certificate is created. We need to have a private key first, and then we create the certificate signing request. Then finally we create a certificate from that CSR. Here I have logged into the server and I am in currently HTTPD directory. I'll make another directory called certs. We will navigate to the certs directory, and this is where we will create our private key. In order to create the private key, I will use openssl command line. So openssl gen rsa with out file which is server.key and then the length of the key. Press enter key. Now you can see we have a server.key file in our directory. Next we will create the certificate signing request. In order to create the certificate signing request, we will do openssl request -new. The key we will use is the server.key. The out file we want to use is server.csr and press the enter key. Once we press the enter key, we will be ordered to enter the basic information about our web server. For the country name, we have to define 2-letter code of the country. I will type CA. And for the province, I will type ON, which is Ontario. The locality is where we are located, so Toronto. Organization should be the company name, but in our case, I will just do iOSCoding. Organizational unit name is where your web server resides in. In corporation, you may have a different organizational unit, but I will just type web server. So common name is usually the server's host name. I will just type Skycrane in this case. Email address, we will do root@example.com. We will type password 123. Press enter. The optional company name is again the company name which you are working for. In our case, I will just do example.org. And now we can see that we have server.csr file generated as well. The CSR stands for certificate signing request. If you want to check the contents of the CSR file, we can type openssl request -in, which is the server.csr file. And then we want to do the text description. If you press enter, you will see different information within the certificate signing request. Here the subject of the certificate is the information we added. There are other information such as the algorithm and the certificate request key as well. Now we have the server.csr, which is certificate signing request, and server.key. We can generate our own certificate. We will use the openssl utility for that with x509 parameter. We will do openssl x509-req, which stands for request, and then the in will be server.csr-sign key will be server.key. We want this certificate to be valid for 365 days. Then we want to save this certificate as server.crt. Press enter, and here we have server.crt ready to be used. You can check the contents of the certificate as well using openssl x509 with in file server.crt and then text. Once you press enter, you can see the certificate contains the similar information which we had seen in the CSR, along with the signature and other algorithm information. One thing to notice in here is the issuer. The issuer is the same name as our company information. That's why it is called self-signed certificate. Now we have the self-signed certificate. Let's try to install it. Right now I am in the etc httpd directory, and here we have bunch of directories within. The conf and conf.d directories are the two main directories where the configuration files reside. Related to your SSL configuration file, you may place that file into conf.d directory. However, in our case, we will edit the main configuration file, which is httpd.conf. Before we install the certificate, we need to make sure that the mod SSL or SSL module is enabled in our web server. We can verify that by Apache CTL -M and then grep SSL. If you see SSL underscore module being displayed in here, that means your server has the SSL functionality available. Next, we will edit the httpd configuration file under conf directory. Here you can see our server by default is listening on port 80. We want to stop listening on port 80 and instead want to use 443. In order to enable the SSL functionality, we have to write down SSL engine on. Then we have to pass the SSL certificate file. So SSL certificate file, this should be an absolute path of the certificate. We have it under etc httpd certs and then the name of the certificate, which is server.cert. Next we will add the key, SSL certificate key file. So etc httpd certs and server.key. Now our web server is ready to listen on port 443. We will save and exit from the configuration file and restart our Apache server. So systemctl restart httpd. Just to verify that our httpd server is running by systemctl status httpd. Here we have our server running and active. Back in the web browser now, if we type https and the host name of our web server, we can see our website is being displayed over the https or 443 port. You may not see a green lock icon which you were expecting because we are using a self-signed certificate which is not verified by any certificate authority. However, this will still do the job to encrypt your data. If you click on connection not secure option, click on more information, you can view the certificate. If you remember, the information being displayed in here is the same information which we entered during the certificate creation. The country, state, and province. Also, the validity of the certificate is for 1 year. In our Wireshark application, let's try to sniff the packets for port 80. If we refresh our page, you can see no data is displayed for that interface. The reason is that because our web server is listening on port 443, not on port 80, nothing can be captured. Now let's try to change this port to 443 and start capturing again. If we refresh our page, you can see the data is being populated in here. What we will do is we will submit our response and new data will appear here again. Now let's stop the capture and try to find out what is happening. Our application is sending some responses over TLS instead of HTTP. If you double click on any of the packets, you can see that the data is actually encrypted. Unlike shown in HTTP request where you could read the form data, everything looks like a garbage text. In this case, if a hacker was listening to your web requests, he will not be able to see what exactly is flowing within the network. Unless they have the key, the decryption of this data will be impossible. And this is exactly why you should be using SSL if you are collecting sensitive information from the customers. That's all for this video. I hope now you understand what SSL is and what it can do for you. Also, you have an idea how you can install a self-signed certificate in your web server. Please don't forget to like and share this video and subscribe to my channel. I will try to create more useful content in the future. Thank you very much.